This is my online bookstore data warehouse project, and I am José Ambrósio. The contents for this presentation includes the introduction, problem statement, proposed solution, designed system, database, data warehouse, graphical user interface, results, conclusion, and the references I used to create this project and the presentation. My objective was to modernize online bookstore operations using cutting-edge database and data warehouse technologies. Online bookstores face numerous challenges such as data management, customer engagement, inventory optimization, and decision-making. Traditional databases also struggle with volume, variety, and velocity of data, and this has a negative impact, such as inefficient data management and analysis and decision-making. So there's a need for a robust database and data warehouse solution for online bookstores to overcome these challenges. My solution was to develop a two-tier database architecture comprising a traditional database and a data warehouse. My approach was to implement a transactional database with MySQL for storing and managing operational data. The benefits include data integrity, consistency, and reliability in transactional operations. To enhance my solution, I also developed a data warehouse using Google BigQuery to aggregate, analyze, and report on data. The advantage of developing a data warehouse is to have a centralized platform for advanced analytics, reporting, and data visualization. To build my database, I used MySQL, which is the foundation for transactional data management of my project. The database includes a schema, which is a comprehensive structure for organizing data entities such as customers, orders, books, authors, and publishers from my online bookstore. Tables were created to define specific attributes or properties associated with each entity. Then, I also created views, stored procedures, and functions. The views served as a crucial tool for providing a simplified and structured approach to data access and analysis. They offer several benefits including data abstraction, data security, simplified queries, consistency and reusability, and performance optimization. The stored procedures play a pivotal role in database management by encapsulating sets of SQL statements into reusable units of work. They offer numerous benefits including code reusability, modularity, encapsulation, performance optimization, and improved security. The functions were created in the database to encapsulate and execute specific logical calculations. They served various purposes including promoting code reusability, enhancing modularity and encapsulation, ensuring data integrity and consistency. Additionally, improving performance, centralizing business logic, facilitating aggregation and analysis tasks, enabling data transformation, and allowing for customized data retrieval based on specified criteria. After developing my database, I developed my data warehouse using the Google BigQuery. I chose to use Google BigQuery because it is an entirely managed, serverless, and highly scalable cloud data warehouse provided by Google Cloud Platform, and it offers a robust platform for storing, querying, and analyzing large data sets quickly and cost effectively. The data warehouse implemented on Google BigQuery complements the transactional database by providing a centralized platform for advanced analytics reporting and data visualization, and it serves as a repository for aggregated and transformed data from MySQL database, facilitating comprehensive analysis and decision making. To create my Google BigQuery data warehouse, first of all, I created my tables, exporting MySQL database tables into CSV files, and then uploaded these files to the data warehouse in Google BigQuery. This process involved transforming the data from its original relational database format into a tabular format that could be easily imported into the platform. Following the creation of the tables, I created the same views I created on MySQL, and then I created routines. The most important thing that was created on data warehouse was data transformation and the query optimization. The data transformation process employed in the data warehouse served several crucial purposes in enhancing the stored data's quality, usability, and relevance. This process involved data cleaning, data enrichment, data filtering, and data aggregation, ensuring that the data within the data warehouse is optimized for analysis and decision making. The query optimization was essential in the data warehouse to ensure that analytical queries are executed efficiently and promptly, especially when dealing with large volumes of data. Techniques such as indexing, partitioning, clustering, and optimizing joins and aggregations were employed to maximize query performance and minimize resource utilization, thereby enhancing the overall user experience and cost efficiency of the data warehouse environment. After creating the database and the data warehouse, I created a graphical user interface using Python and the Tkinter library to provide the user-friendly interface for interacting with the MySQL database, including features such as table visualization, event handling, and seamless connection. This is the graphical interface of the online bookstore database and data warehouse application. After the user opens the application, the user can click on Display Tables to visualize all of the tables included in the database. For the user to see the data from a specific table, he just has to click on the name of the table, and then he can see all the data from a specific table. In this case, this is the table address. So we have here our columns and all the rows of the table. If the user wants to see another table's content, he just have to click the same way on the top of the name of the table. In this case, we will open the book table, and then we can see all of the content in the table book, including the title of the book, the ISBN, the number of pages, publication date, the price, and other columns such as publisher ID and book language ID. This is the database entity relationship diagram showing each table and its columns. This diagram helps people to have a visual representation of the database schema. I will run this view to show the average pages per book by each specific author. So we have the author name and the average pages. Here we have another view showing the high value customers. We can, for example, see here that Dorothy Ramirez is the customer that spent the most on our online bookstore. We can run this story procedure called Get Order History. I will insert the number 1. And then we have here for the order history of this specific order, the order number 1, we have here all of the status and the dates. And we can have, for example, a function called average pages per book, showing the average pages per book. So on average we have 437 pages per book. Now I will show the data warehouse running on Google BigQuery. Here I have my online bookstore dataset, including all of the tables, views, and routines. I'll show all data in this table. And here we have all of authors' information, including their names, phone numbers, and email address. Here we have a view showing the top customer locations. And we have another view showing the total revenue for each shipping method. We can see that the express shipping is the method with the higher revenue, followed by the standard shipping, and then followed by the next day shipping. On my data warehouse, I made a data transformation in order to clean data. I cleaned all of the rows that include empty values, so now I don't have any missing value in any record on my tables here on my data warehouse. Following this step, I also enriched the data, adding a column called publication year, which extracts the year from the publication date column. So here on my table called book with publication year, besides the columns I have on my original book table, I also have the column called publication year in order to facilitate the year extraction when running queries. Also, I did data aggregation, calculating the total revenue generated by each book, and then I stored on my book revenue table. This is a view that shows only the title of the book and the total revenue. I also did query optimization, creating indexes on frequently used columns to speed up query performance. For example, I created an index on the customer ID column in the customer order table. Also, I optimized joins and aggregations, rewriting the query to find the total revenue generated by each book using the aggregated table book revenue. The implementation of the online bookstore data warehouse project has yielded significant improvements in online bookstore operation and decision-making processes. Through the development of a robust database and data warehouse solution, online bookstore operators now have access to centralized real-time insights into customer behavior, sales trends, inventory levels, and marketing effectiveness. This enhanced visibility has enabled them to optimize inventory stocking, streamline order fulfillment, personalize marketing campaigns, and improve customer engagement. Additionally, the project has facilitated the development of advanced analytics capabilities, including predictive modeling, customer segmentation, and trend analysis. These analytical tools empower online bookstores to anticipate market trends, identify growth opportunities, and mitigate risks effectively. To conclude, this project represents a significant advancement in e-commerce data management and analytics. By leveraging state-of-the-art database technologies, this project has enabled online bookstores to unlock valuable insights from their data, improve operations, and make data-driven decisions that drive businesses' growth. The project's findings underscore the importance of investing in robust database and data warehouse solutions to remain competitive in the fast-paced domain of online retail. Moving forward, the insights and methodologies developed through this project can serve as a blueprint for other online retailers seeking to harness the power of data to drive innovation and success in their respective industries. Those are the references I used to develop this project and also create this presentation.